Welcome to this third video of design patterns, where we will have a look at the Abstract Factory design pattern. Before watching this video, make sure that you have also seen the introduction to design patterns and also the video about the factory method. In further videos, we will have a look at the singleton design patterns and then structural and behavioral design patterns. Before starting with the Abstract Factory, I will recall you about the factory method design pattern. So remember, this was a design pattern that was used whenever we have a class creator that needs to be independent on the subtype of product that is going to be created. So this creator class knows that the class needs a product, and therefore this creator class will define a method, a factory method, that is abstract or can have some default code. But the idea is that by providing a concrete creator subclass, this concrete creator will decide which subclass of product it will be created. So the idea is that by overriding this factory method, I decide that I will create a concrete product subclass. But here, all the code of this creator class will be independent, will be the same, because this superclass will call this factory method and then will be overridden in different subclasses. In a running example, we have a bunch of factory methods here that create different types of objects. For example, mazes, walls, rooms, doors, and so on. And then we have here code that relies on these factory methods here. The idea here of the factory method is that then you will create a subclass of maze game, a concrete creator that will override these methods here, but this code will still work and then will change what type of object will be created, because here I can create subclasses of maze, of room, and of door, and so on. Well, the Abstract Factory builds on factory methods. The problem of that Abstract Factory is trying to solve is to provide an interface to create families of objects, not just one single object, but a family of objects. For example, in the running example, we would be interested in creating families of mazes, families of labyrinths, for example, enchanted labyrinths, bombed labyrinths, and so on, where we need to make sure that all the objects that are created belong to the same family. This design pattern is also known as kit, and I will provide another motivation. Suppose you are building a manager for user interfaces that allows several look and feel, different styles for the different objects, like windows, buttons, scroll bars, and all these things. And this is very common, no? In operating system, they have different styles. For example, in early versions of Unix, you have the motif and the presentation manager. These are two different styles of user interfaces, and of course, every time an application needs to create a widget, if it's using motif, then this widget should be presented using the motif style. So how to ensure that you provide such an interface such that client code can be consistent and create always, whenever you create a window, you create a motif window or a presentation manager window without doing something special. So the idea is to create an abstract class widget factory, and then to create subclasses that will create an object of the given type. So by using this abstract factory, the client code do not depend on particular invocations to different constructors. And so that's the idea here. So you will have a widget factory that will have factory methods for each possible product that I want to create. So I want to create, in this case, windows and scroll bars, but of course, in a real graphical user interface management system, I would also have buttons, tables, lists, combo boxes, and so on. all these would be the products that I need to create. So for example, here I have the hierarchy of products for windows and the hierarchy of products for scroll bars. And so what's the idea? Okay, so that is to have a hierarchy of products for each type of product, for example, for windows, for scroll bars, and then we'll have a subtype for each style. For example, I have a presentation manager window and motif window. If I would have further styles, I would have further subclasses here. And same thing for a scroll bar. So I have the product, the scroll bar, and then concrete products here for presentation manager and motif. And then I will have two specific factories, one for motif widgets, where I override all these methods, creating the appropriate type of product. For example, here in the motif, I create a motif window and a motif scroll bar. And same thing for presentation manager. I create a presentation manager window or presentation manager scroll bar. And so what's the benefit of this? Okay, then the clients will use factories to create the products. So you can configure client code by passing a concrete factory, right? But still, the code of the client can be general because it relies on this interface here, which is provided by this widget factory, and then by using a different factory, the client code still remains the same, but everything that is created will be configured with the different styles. Right, so when are you going to use the abstract factory? Well, exactly for the problem we have seen, where you have a family of products that needs to be created and the client code needs to be consistent with these different families. So you cannot create products of different families. You want to forbid that. And you want to configure this system with the family of products that needs to be created. Also, when you want the client code to be independent on how the products are created and represented. Right, so this is the generic template for the abstract factory, and recall it's important to know what's the structure, but also what are the role names, right? Because this will be important when you want to communicate with your fellow programmers. So we have the abstract factory. And the abstract factory is typically an abstract class. It can also be concrete, but normally it's abstract. And you will have abstract methods to create each different product. Here we have two products, but you may have more than two, right? And here these are basically factory methods. They can be abstract, as in this case, but you can also provide a default implementation. And then you will have concrete factories, which are concrete classes that override these factory methods here. So here we have two concrete factories. You have a concrete factory for each product type. So I have here two styles for product A. So I have product A2, product A1. This product A2 is created by the factory 2, and product A1 is created by the factory 1. So whenever I call create product A, factory 1 will create product A1, and whenever I invoke create product A on factory 2, it will create product A2. And same thing for product B. Well, the consequence is that you keep your clients independent, the client code independent from the implementation classes by using these abstract factories, and it helps to replace product families. So if you have the presentation manager style, you can change it very easily by the motif style. And it promotes consistency, because if the client can only create those objects by using the factories, then you cannot really mix styles for different products. On the bad side, it's difficult to add a new product, because if you add a new product, for example, let's say you have the example of the graphical user interfaces, and then you need to add support, let's say, for trees, which is a new product, then you need to create an abstract class tree, then each subtype of tree, then you need to add a new factory method to the abstract factory, and then a new you need to override these methods in each concrete factory. So it's a little bit of a heavyweight design. Right, so let's have a look. Let's come back to a running example of the labyrinth. So what we do here is we create an abstract factory. Recall, an abstract factory is a class that contains factory methods and only factory methods. Here we are implementing a variation of this design pattern where we provide default implementations for the factory method, creating maze, wall, room, and doors. But the idea here is that you could have concrete factories that subclass maze factory and provide other implementations for all these methods here. For example, I could have an enchanted maze factory, a bombed maze factory, and so on. And the idea is that every client code that needs to work with creation of mazes will be configured with this with an abstract factory like here. So I have here this create maze method that receives a factory and will use this factory to create the different elements, right? And so the idea is that this method will create the different type of labyrinths if we provide here a different concrete factory. So we could pass as parameter an enchanted maze factory or a bombed maze factory, and then the products that are created here will change the style. And I don't need to change this algorithm here. Right, with this we finish the video about the abstract factory. I recall here the bibliography that you can consult, and in further videos we will have a look at the singleton design pattern.